All right, so I'm going to start with 3.5, which are compound Boolean expressions. So if you remember from last week, we were talking about if, else if, and else statements. And basically, if something is true, then it goes into that statement. And if it's not, then it skips it. So often you want to have a little bit more complicated things than just one statement. So let me create a new REPL, Java. So the example that they have in the textbook there. So again, we're dealing with Booleans. So Booleans can only be true or false, as you can see here. And a simple example that they have is if you cleaned your room and you did your homework, then you print you can go out. Otherwise, no, you can't go out. So depending on how we set cleaned room and did homework, you're going to print out different things. So if both of them are true, then you can go out. So what this double ampersand sign means is literally and. So both of these have to be true for this whole thing to be true. If either one of them is false, then the whole thing is false. And or does what you'd expect. If either one of these is true, then the whole thing is true. So if either you cleaned your room or you did your homework or both, if both of them are true, then it's also true. It doesn't matter as long as at least one of them are true. There's a different kind of or called the exclusive or, which means that not both of them can be true, but you don't usually, it's pretty rare to see that in this type of programming. It's used in different stuff, but so that would be like, are you going to ride your bike or drive your car to school today? Right? You can't ride your bike and drive your car. That's exclusive or. But these two pipe symbols, which are above the slash on the right-hand side of your keyboard, shift slash will give you the pipe symbols, mean inclusive or, so either one can be true. And they have an order of precedence as well. So, cleaned room, did homework, empty dishwasher, false. This is not totally clear, right? Because you don't know if it's empty dishwasher and cleaned room, right? Like which takes precedence, the and the or, right? Which one is stronger? So the strongest one is the and symbol. So in this case, it would be dishwasher and clean room or homework. So if dishwasher and clean room are both false, but homework is true, it will still print you can go out. Because even though this half of it is false, right? Dishwasher and clean room is false. Those are stuck together in one. It's like you put parentheses around them. So, and sticks things together really tightly more than or. So Java will evaluate these two things, and then it'll say, oh, here's another or, did homework. So if did homework is true, then it doesn't really matter whether this is true or not, because remember, either or. If I did my homework, then I get to go outside. It doesn't matter what these two are. Does that kind of make sense? That can be confused. They can try and trick you with that in the AP questions. So I want to make sure that that's clear. So if that makes sense, just type a plus in quickly. And if not, type a minus. Okay. Okay, good. So just remember that and sticks things together tighter than or does. So the other symbol that you need to know is the not symbol. And the not symbol is an exclamation mark. Let's add something new. What is something bad? Boolean slept late equals so if you did not sleep late, then you can go out. So what you do is you put an exclamation mark in front of it, and that means not. So whatever this is, the not takes the opposite of that. So it's going to say you can go out because slept late is false and not slept late means true. And so you can use not for a lot of things. You can put it in front of parentheses. So if you did not sleep late, and I don't know, cleaned room. All right, so slept late is false and cleaned room is false. So this whole thing in the parentheses is false, but this not will make it true. If I put something, if I make this true, did homework. Did homework, right? So now it says slept late is false or did homework is true. So this whole thing is true because as long as one of these, remember, or is if this is true or this is true. So did homework is true. So that means this whole thing is true. But I have a not here, so that makes it false. So it's going to say, no, you can't go out. So this is starting to get a little bit confusing, right? Because you can have nots and ands and ors and all this kind of stuff. So one thing that we can do to make sense of this is something called truth tables. So I'm going to get a sheet of paper here. Hold on a sec. Actually, you know what? I can just do it in a Google Sheet. That might even be easier. All right, so let's say did homework is true. Washed dishes is false. Okay. So actually, you know what? I want truth tables work a little differently. Washed dishes. Did homework and washed dishes. Right. So the way you make a truth table is you go through all the possibilities of these two guys and you put the result of what that would output here. So true, false, true, false is true, true, false, false, right? So these are all the possibilities. They can both be true. Did homework can be false and wash dishes could be true. Did homework could be true, wash dishes could be false, or they could both be false. So what is the result of this and for both of them? So and means they both have to be true for this whole thing to be true. So did homework is true and wash dishes is true means that's true. Did homework is false and wash dishes is true? Well, that means that this is not true because did homework is false. So it's not true that both of them are true. So this is false. Same thing for if wash dishes is false. And if they're both false, then obviously this is also false. So that's how truth tables work. So I'm going to do the same thing down here, but I'm going to do it for or. So if either one of them is true, that means this will be true. So if both of them are true, yes, that's true. If wash dishes is true, that's true. If did homework is true, that's true. But if both of them are false, then did homework or wash dishes is also false. So those are pretty simple examples. You can start getting, more complicated by doing something like, not did homework and wash dishes. That starts getting a little trickier. Not did homework and wash dishes. So did homework and wash dishes? Yes. So that would be true, but the not makes it false. This makes the inner parentheses false, but the not makes it true. This one, did homework and wash dishes? No, but then the not makes it true. And if we look to check our work, we can say, well, this is just the opposite of this guy up here. So all of these values should just be the opposite of all of these values because it's just not this guy. Oops. So the first is false, which is not true. The next three are true, which is the same as not false. So we did it right. So that's how truth tables work. They're just a handy tool to check what the output depending on what the input is here, all the possibilities. And you have to remember that you have to check all the possibilities, not just one or two of them. So this is another example of truth tables in here. All right. Oops. Think All right, let's give me another plus minus squiggly for truth tables. Feel pretty good about those. Okay. So the next thing to talk about, these are De Morgan's laws, which sounds really fancy, but all it means is a way to kind of make things a little more simple. So when you see something like not did homework and wash dishes, there's a way to kind of make that a little easier to think about. And this guy De Morgan figured out that not did homework and wash dishes is the same thing as not did homework or not washed dishes. And it's literally, you end up with the same truth table. So not did homework means not true, which means false. Not wash dishes, not true, which means false. So false or false is false. Not did homework, not false, equals true. Or not wash dishes, not true is false. So true or false is still true, because as long as one of them is true, the whole thing is true. Same thing here. Not true is false, not false is true, false or true is still true, as long as one of them is true. Same here. Not false is true, not false is true, true or true is true. So you can see that these two things, you end up with exactly the same truth table. So if you want to think about it in English, the way I think about it is, did you do both of these things? Did homework and wash dishes? If you did both of those things, then it's not true, right? Because it's not this and this. So that's the same thing as saying, if I did not do either one of them, then the result is true. If I did not do both of them, that's the same thing basically as saying, I didn't do at least one of them. So if your parents say, if you did not do your homework and wash the dishes, you can't go outside, that's the same thing as saying, if you forgot to do your homework or you forgot to wash the dishes, you can't go outside. So logically, it's the same thing. And that's why the truth table shows you the same thing for all the possible options. So these are not things you really have to memorize. They have an example here of like, you know, an example Boolean expression simplified. I don't really know that that's a lot more simple, but the questions you're likely to get are these two expressions equivalent? Right? Is not x less than 3 and y greater than 2 the same as x is greater than or equal to 3 or y is less than or equal to 2? And you just have to be able to, either using a truth table or logic or however you want to do it, be able to say whether they are the same or not. So you can see here, are these three expressions equivalent? And it just asks you to try them out. And so that's like a question you might get, a multiple choice question on a quiz or on an exam. Which of the following is the same as the code below? So again, you don't need to memorize De Morgan's laws, you just need to understand them. Yeah, here's a good example of an AP question. Which of the following describes, so let's go through it. Which of the following best describes the value of the expression A and not B or A? All right, so I'm going to put this in here. And I am going to make a truth table because that's the easiest way, A and B. And again, I can do it whatever order I want, but I'm just going to copy this as long as it does all possibilities. All right, so this I could separate out into not B and not A if I wanted to using De Morgan's laws. So I can use either one of these. They're going to end up equivalent. So I'm just going to go through it quick. So A is true. And yep.
We can't see the sheet that you're typing on.
Awesome. Thank you. So I was just saying that these are equivalent because not A or B is the same as not A and not B. Just like not A and B, the same as not A or not B. So those are De Morgan's laws, and you can check them if you want. But anyway, the point being for this kind of question, actually, I'll just leave that there. The best way to go about it is just to make a little truth table. So A is true and not B or A. So B or A is false right now, but not B or A is true. So A is true and not B or A is true. So this whole thing is true. A is false, so we know this whole thing is going to be false because this whole thing relies on both sides of that and being true. So if A is false, we know right away the whole thing is false. And that's called a short circuit. And that's what Java does as well, is it goes from left to right, and if this side is false and the rest is an and, there's no point even looking at the rest of it. There is no way for this whole thing to be true if A is false. It's just not possible. So if A is false down here, we can put false here as well. So what about this though? True and false. A is true, so the left half is fine, and not B or A. So B or A, is one of these true? Yes, A is true. So inside the parentheses is true. If we not that, it makes it false. So this is also false. And we can check it with this one on the right, and we know A and not B and not A. Wait a minute. I messed this up, didn't I? I did. Sorry, I messed it up. Because B or A is true and not B or A is therefore false. So the whole thing is false. Sorry, I'm surprised somebody caught that. So here we have the same logic, so we should end up with the same thing. A is true and not B, and not true. So this is going to be false right off the bat. A is false, so we know that's going to be false. A is true and not B is true and not A is false. So this is all false. And A is false, so this whole thing is false. They match up. And if you look at this closely, what you'll notice is inside it, it has an A and not A. So that's never going to be true. And that's where I figured out my error, was when I looked at this and I was like, wait a minute. How can any of them be true if you have an A and not A? You can't, because if A is true, then not A is false. And if A is false, then A is false. So it's going to be false no matter what, regardless of what B is. So this is a bit of a trick question. So let's go back into the assignment and see what our possibilities are. Which of the following best describes the value of this? The value is always false. Yes. So they converted it to using De Morgan's laws, A and not B and not A. And they said, since A and not A can never be true, the whole thing will always be false. All right. Give me another plus minus squiggly on like this logic.